In this video, we are going to discover how to make and use navigation meshes to create walkable paths for moving agents. Before we start though, make sure you watch this tutorial in which I explained a lot of stuff that we are going to use, like what is an agent, a vehicle, a steering behavior, and the follow path behavior. So what is a navigation mesh, you might be asking? Well, according to Wikipedia, a navigation mesh is a collection of two-dimensional convex polygons that define which areas of an environment are traversable by agents. In other words, a character in a game could freely walk around within these areas unobstructed by trees, lava, or other barriers that are part of the environment. So basically, a navigation mesh is a mesh that represents where an agent can walk. To create a navigation mesh, we are going to use Blender. However, keep in mind that the latest version of Blender that supports this feature is 2.79, so you may find yourself working with two versions, the latest one for modeling and the 2.79 for the creation of the nav mesh. That being said, Google Blender 2.7, hit download Blender 2.79b, and then choose the file depending on the operation system that you have. Once installed, we'll need to add a plugin in order to be able to export glTF and glb files, because this version of Blender doesn't support that by default. To do that, we are going to download the glTF-Blender-Exporter plugin. I'll leave you the link to this repository in the description below. So hit code and download the zip file. As you can see here, I have already downloaded and extracted it, so what we are going to do next is go back to Blender, hit File, User Preferences, File, Scripts, then go to the location of the unzipped folder, go to Scripts and hit Accept. Next, push Save User Settings, close and reopen the application. Finally, go to File, User Preferences, Add-ons, type glTF in the search bar, and then fill the checkbox and hit Save Settings. Now, if we go to File and Export, you see that we are able to export glTF and glb formats, and that's it for the configuration of Blender. And now it's time to create a sort of a map for our agent to work on. With that done, to create a nav mesh for this map, select Blender Game on this list and then open the navigation mesh drop-down. Now if I hit navigation mesh, we get this blue square which represents the walkable area on the map, although it doesn't match the structure of our map obviously. So I'll hit Ctrl Z to undo and play a bit with these options. The first option we are going to tweak is the cell size, which I'm going to reduce. And now if I hit build, we get a better result, but it's still far from being perfectly matching. So I'll undo again, and this time I'm going to reduce the radius of the supposed to be agent. I'll hit build again, and now we've got a pretty good result. But still I'll undo again to reduce the value of the height, which represents the height of the agent. Essentially, you're going to spend some time playing with these options to get the perfect result for your case, like the cell height, which represents the space between the nav mesh and the map, to prevent the collision of the agent with the actual map. And now that we've got a good nav mesh, we still can modify it. So with the navigation mesh highlighted, select the edit mode, and now we can edit the faces, the edges, and the vertices like we would do with a regular mesh. The final step before we jump into the coding part is to export the map mesh and the navigation mesh individually. So with the map selected, I'll go to File, Export, GLB, then I'm going to choose the location and make sure to check Export Selected Only. Next, I'll select the navigation mesh and do the exact same steps. As you see here, we have this scene that contains just a cone which represents the agent. And this is the code behind it, which I explained in detail in the video that I've told you about earlier. The only thing that may confuse you here is this line. So, if you look at the line right above it, you see that I didn't pass a path to the constructor method because we don't have a constant path for the vehicle to follow, since we are going to create a new path every time a mouse click event is captured. The problem with that though is that the steering behavior is activated by default, which means that the vehicle will automatically try to follow the path, which doesn't exist here, hence it generates an error. And it's for that reason that I set the activate property to false to prevent it from starting at the load time, and of course we'll activate it later on when we make the agent move. This property matches the second argument of the constructor, which I did explain in the other tutorial. Having said that, let's load our map. That done, now to load the nav mesh we need to create an instance of the nav mesh loader. Next we'll call load from that instance, and that's it pretty much. If we take a look at the scene, as you can see nothing has changed, which is how things are supposed to be. A nav mesh is not supposed to be displayed, but just give information about the areas that the agent can have access to. However, we still need a way to display the mesh for debugging purpose. To do that, we have a couple of helpers. The first helper we are going to use is the graph helper, which shows the set of paths that the agent could take to reach a certain position, connected by a certain number of nodes, aka checkpoints. To add the graph helper, we'll need to copy this part of code from the Yuka repository and paste it in a new file. Next, we'll fix the path to Three.js and export the create graph helper function. Now we are going to import it within our main file. The next step we are going to do is create a reference to the navigation mesh and a variable in which we'll put the graph of the nav mesh. And now we'll create another variable which will contain the graph in a form of a group that we can eventually add to the scene. The second argument of this function is the size of the spheres that represent the checkpoints. And that's the graph of our nav mesh. The second helper we are going to see is the convex region helper, which displays the walkable areas with random colors, pretty much the same as we've seen in Blender earlier. And we're also going to use this helper to move the agent on click in the next section of this video. So again, we are going to copy the code from the repository, paste it in a new file, and then import the create convex region helper function in the main file. Next, we are going to call that function which returns a mesh that we'll add to the scene. In this section, we are going to move the agent on mouse click, and to do that, we are going to use the raycaster. If you don't know what is the raycaster, make sure to watch the dedicated part in my Three.js guide. I'll leave you the link in the description below. Now here we are going to call a function that we'll create in just a second. The argument of this function is a Yuka vector 3 that contains the coordinates of the mouse click location. Within this findPath2 function, we are going to define two variables that represent the two ends of the path that the vehicle has to follow. From is the current position of the vehicle, and to is the position of the mouse click. Next, we are going to create the path that connects the two ends by calling the findPath method from the Nav Mesh. This method basically does some calculations behind the scene and returns the shortest path that leads from the start point to the end one. And now all we need to do is modify the follow path behavior of the vehicle. So this line will get us a reference to the follow path behavior. We'll need to activate it since we deactivated earlier, if you remember. And we'll clear the old path and refill the path property with a new path every time a click event is captured. Finally, we are going to move this block of code into the dam body. And there we go. Even though the result looks fine, we still got sort of a hidden problem. So first, let's get rid of the helpers. Now let me put the vehicle in a straight line with a target position that has a higher Y value and see what will happen. As you can see, the agent gets directly to the target position without remaining at a reasonable distance from the ground. And again, the problem occurs from this side too. So here's what we are going to do to fix that. First, let's create a couple of global variables that we are going to assign the mesh in the vehicle to. Next, we'll make an if condition to run the code only when the navigation mesh is loaded. And within this block, we are going to call getRegionForPoint, which will return at which convex region the agent is currently in. Next, we are going to create another if block, since getRegionForPoint can return null sometimes, which could generate some errors. Now, within this block, we are going to call DistanceToPoint, which will return the distance between the agent and the convex region. And then we'll do just a little bit of math to make sure there is a certain distance that must be maintained between the agent and the ground. That done, let's give it a try. And there we go, problem fixed. Lastly, even if this solution works fine, we still have room for improvement in terms of code organization. A cleaner solution would involve making this kind of modification as an internal mechanic to the agent. And what I mean by that is to hide this logic within the vehicle code so we don't have to add these lines to the animate function, especially in a case where we would have more than a single agent. Essentially, what we are going to do is create a custom type of vehicle that will have this logic by default. In that way, all we'd need to do is create an instance of that class without worrying about creating global variables and all that stuff. To do that, I'm going to create a new file for the custom vehicle, import the vehicle class, and create a custom vehicle class that inherits from it. If you're not familiar with the OOP way of JavaScript, I highly recommend you watch this video in which I explained all the stuff we are going to use here. So the constructor of this class will take a nav mesh as a parameter, since it's crucial to set the position of the vehicle on top of the ground. We also need the update method inherited, and then we'll cut the code we typed earlier and paste it here. Now we are going to change every position with the keyword this, which refers to the current vehicle. And we'll also change the nav variable with this current object's nav mesh. Finally, we'll return this object and export the class. Now, in the main.js file, we are going to import the custom vehicle module. And we are going to get rid of the newly added global variables and just create an instance of the custom vehicle class instead of vehicle, and that's it. Make sure to like and subscribe, and I will see you in the next video.